Hello, grade 8 students. In this video, I'm going to explain two lessons that are related. The first one is the rational expression, and the second one is the compound fractions. So both of them, they talk about fractions. Let us start with the first lesson, which is the lateral fractions. So we're going to define what's the meaning of a lateral fraction. We're going to simplify, and we are going to perform some operations on the fractions like addition, subtraction, multiplication, and division. Let us start first. What's the meaning of a literal fraction? A literal fraction is a fraction that contains variables, contains letters, like 3 over 7b. You used to have a fraction when you have the numerator and the denominator are numbers. Now we're going to deal with fractions that have in the numerator or in the denominator or even in both letters. You're going to see that we're going to have the same steps on the numbers we're going to do on the letters. So a literal fraction contains letters, and it's defined when the denominator is different than 0. If you just put inside of you the calculator and you put 5 over 0, you're going to have syntax error, because in the denominator we can't have a 0. We can't divide the 5 by 0. Okay, you already know this because it's impossible to find something to multiply it by 0 and you get a number. This is impossible. So I can deal with fractions that have letters in the denominators just in case we take a condition. We take a condition. What's that condition? In the first one, we have 1 over b. I can use this fraction just in case I tell them that the b is not a 0. Because if you have 1 over 0, you're going to have a syntax error. So b could be any number except 0. So what I'm going to write is the fraction exists, or the fraction can have an answer if the denominator is not 0. So b is not 0. Okay? So every time you're going to take this condition just to deal with the fractions properly. Okay? So just you take the denominator different than 0. So b is different than 0. Is not equal. When I say different, means is not equal to 0. 1 over x. Also, 1 over x works out properly for all the numbers except when the denominator is different than 0. Okay, so we have to take x is different than 0. So x could be 1, 2, 3, minus 1, minus 5, any number except 0. 1 over a minus 4. This fraction exists every time you're going to write this sentence. The fraction exists if the denominator is different than 0. So a minus 4 is different than 0. When does that happen? When a is not 4. So if you just replace instead of a 4, you're going to get 4 minus 4, which is 0. So a could be any value except 4. You solve it as if you're just doing an equation. Look, I'm going to do it aside. So a minus 4 is different than 0. As I told you before, you're going to take the numbers to the other side. So you take the minus 4 to the other side, as you can see. So now it's a different than 4, because when you take something to the other side, you change its sign. So if it's negative, it becomes positive. So a is different than 4. When I say a is different than 4, a could be any number except 4. Let us continue. 3y over y plus 2. So also y plus 2, I have to take it different than 0. Y plus 2 different than 0. You take the plus 2 to the other side, so it becomes y different than minus 2. So y could be any number except minus 2. Okay, and let us continue to x minus 5 over 3x plus 1. Also 3x plus 1 should be different than 0. You take first the minus 1 to the 1 to the other side, so it becomes minus 1. And now what's the number? You multiply it by 3 to get minus 1. You just take the 3 down, so it's x different than minus 1 over 3. Okay, so we take the 3 down because it's multiplied with the x. To the other side, it becomes division. So it's minus 1 over 3. So x could be any number except minus 1 over 3. Now the properties. The only properties that you're going to take in this lesson is minus a over b. It's the same as a over minus b. It's the same as minus a over b. So if you have like minus 1 over 3, it's the same as 1 over minus 3. It's the same as minus 1 over 3. And that's the form that we always prefer, is to put the minus in between them on the line, okay? But if we have minus a over minus b, it's a over b, because the minus and the minus goes out. They are simplified. Minus divided by minus is plus. So they go out, and the answer is a over b. In this exercise, the question is, in which case are the following fractions defined? So you're going to do exactly the same as I did in the previous exercise. So you're going to tell me that this fraction is defined for a different than 0, okay? I advise you to solve this exercise. If you check the lecture PDF, you're going to find the answers to check your answers. Okay, you're going to find the solution in order to check your answer. So please, I advise you to solve these alone. And when you are done, just go and check the PDF lecture. You're going to find the answers, okay? Now let us start with something new, which is simplifying fractions. Do you still remember when we used to simplify a fraction like 12 over 18? We used to divide both terms by 6 until I get the irreducible fraction. We're going to do the same here, but you have to know that I can simplify a sign, a number, and a letter. Sometimes I might simplify all of them, sometimes two of them, sometimes only one. So it depends on the fraction itself. So to simplify a letter fraction, it's to find the common factor between the numerator and the denominator. And the common factor, it could be a number, it could be a sign and a number, it could be a sign and a number and a letter. So it depends on the fraction itself. Let us take an example. 3 over 12x. I can divide both by 3. So the only common is number. So I divide by 3 and I get 1 over 4x. 25x over 15xy. So the common factor in this case, it's a number and it's a variable. So 5x, because both of them, they have 5x. So what you do is 25 divided by 5 is 5. 15 divided by 5 is 3. The x and the x, they are simplified. So what's left is 5 over 3y. Let us check this one here. Can I divide the sign? Is there any minus up and minus down? No. So you just circle it. Circle the minus, not to forget it, okay? So you copy it directly here. Now 20 over 32, what's the common between 20 and 32? What's the number that you can divide both terms by? It's 4. So 20 divided by 4, it's 5. 32 divided by 4, it's 8. Now let us check the x. X to the power 3, x to the power 5. So there's only x2 left. Where? Down, because x5 is greater than x3. So I can have here the x to the power of 2. Y to the power of 4 and y to the power of 4, they cancel out each other. Z to the power 3 over z to the power 2. I divide both of them by z to the power of 2. So what's left is z up. So that's the simplest form of the fraction. I'm going to simplify some of these fractions, and you're going to have, of course, a homework. Let us do the first one. We have 5a over 10b. So the only common factor is 5. So I divide both terms by 5, so I get a over 2b. Now minus 21xyz over 35xyt. As I always advise you, if the minus doesn't goes out, just circle it in order to remember the minus, okay? This is very important, just circle the minus. Now the answer, 21 over 35, I'm going to divide both of them by 7. The x and the x, they goes out. The y, they go out, sorry. The y and the y also, they go out. So what's left is minus 3z over 5t, and that's the simplest form. Now mn squared over mnf. What's the common factor between them? Of course, the m. and 1n. So I'm going to divide by mn and mn. So the m goes with the m, n squared with n. What's left up is n over f. 3mn over 2em, the only common between them is m. So the final answer is 3n over 2e. Now 6c squared over 24bc. I'm going to divide both terms by 6 and both terms by c, right? So the answer is c over 4b. 12amx squared over 4a squared mx. So I'm going to divide both terms by, first of all, 12 divided by 4 is 3. 4 divided by 4 is 1. M goes with the M. X is squared and x is left up in the numerator, and a with a squared, a is left in the denominator. This exercise down, I advise you to solve it alone. As I told you before, the solution is found in the PDF lecture to check your answers. Now, if I want to find the numerical value of a literal fraction, you know that a fraction, it has letters. Now we're going to find the value when I replace the letters by something given. Like, suppose here we have x minus 7, and I told you that x is 10. So you replace the x by 10. 10 minus 7 is 3. So we say that 3 is the numerical value because I gave you a specific number for x. It might be changed. I might give you every time a different value for x, and I ask you to calculate. Now 3x squared minus 5x plus 4, I'm going to replace every time this I see the x by 2. So 3, 2, don't forget the parentheses because you have to square x, okay? So the final answer is 6. It's only calculation as long as you know how to replace the values. Here we have 3a minus 5 over b cubed plus 4 minus 2b. Here I have two variables, a and b, and I gave you a specific value for a and a specific value for b, and I ask you to replace them. So this is the final answer. In this question, you have to find the numerical value of each of these, but I'm not going to solve them. Practice them alone, and again, the solution is found in the PDF lecture. And now we're going to perform operations on literal fractions. So as I told you before, we're going to add, subtract, multiply fractions. So let us remember them together. If you want to add and subtract literal fractions, the first thing you have to pay attention is if they are like fractions or not. If they are like fractions, like in the denominators you have the same thing, you can add the numerator directly. But if you have unlike fractions, that means you have to find their common factor. As we used to do in numbers, let me just remind you of something. If you have, for example, 1 over 2 plus 1 over 3, these are unlike fractions. So I multiply this fraction by 3 and this fraction by 2. Okay, the same thing here we are going to do. I have in the numerator b and d, so I'm going to multiply b by d and d by b. Okay, and as I multiply the denominator, I have to multiply in the numerator. So the denominator is bd, and in the numerator I have ad and bc. AD plus BC, it's AD plus BC because I can't add unlike terms. The same thing in subtraction. So I first make them like and then I subtract them. Okay, let us solve some applications on this. We have x over 10 plus minus x over 10. So what we are going to do is to multiply, I have a fraction first. A over 4 plus b over 4. Here I have like fractions, so I add them directly, so it's a plus b over 4. But in the second one, these are unlike fractions because I have 5 and 10. So I'm going to multiply the 5 by 2. So, as you can see, I multiply them by 2, so I get 2x over 10 plus minus x over 10. Now I have the same denominator, which is 10. Can I add the numerators? Yes, because they are like terms. 2x and x are like terms. So 2x plus minus x, as if I'm doing 2x minus x. So it's x over 10. Do you still remember when I told you that you can put the minus on the line? That's what we did here. I told you that you can put the minus on the line, so it becomes 2x minus x, which is x over 10. Now here we have 6x over y plus minus 5x over minus 3y. This is the second property where I can cross out the minus, simplify them. So I get 6x over y plus 5x over 3y, and I do the same denominator, like I just multiply the first one by 3 because I have in the denominator y and 3y. How do I do them the same? I multiply y by 3, so I get 3y. So now I have 18x over 3y plus 5x over 3y. Now I have the same denominator and I have like numerators, so I add them. I get 23x over 3y. So these are very easy. I advise you to solve them alone and check your answers in the PDF lecture. But what I'm going to solve one again, just this one. Here you have and the denominators 5 and 10. So I'm going to multiply the first fraction by 2. But in the first fraction, the numerator, I have 2 minus a. That means I have to multiply both of them by 2. So 4 minus 2a. Because times 2 is for the whole term. So 2 times 2 is 4. 2 times a is 2a. So 4 minus 2a. Okay? And now I put them on one fraction, 4 minus 2a plus 3a. I have minus 2a and 3a like, so I add them. So the final answer is 4 plus a over 10. The others are similar. Just check your answers when you are done, okay? Now in the multiplication and division of fractions, it's also the same thing. Do you still remember when I told you in multiplication, you have to simplify then multiply? The same thing we're going to do here. And in division, what do? We do keep, switch, flip. Do you still remember? Like when we have 5 over 7 divided by 3 over 14, keep the first fraction. Switch the division into multiplication and flip the second fraction. And now what do you do before you multiply? Simplify, then multiply. So the answer is 10 over 3. The same thing we're going to do in letters. Let us solve some of these. I'm going to solve one multiplication and one division. So I'm going to solve number 1 and number 4. In number 1, this is multiplication. So as I advise you to simplify then multiply. So the 3 goes with the 3. And 2 divided by 2 is 1. 4 divided by 2 is 2. So the final answer is AB over minus 2. So when you are done from simplifying, you just multiply the numerators together and the denominators together. I'm not going to solve the others. In number 4, as you can see, keep, switch, flip. Keep the first, switch to multiplication, and then flip the second fraction. So now you can simplify the y with the y, the x with the x, and the final answer is 1. Okay, the others please try to practice them, and the solution is found in the PDF lecture. Now we're going to start with the second part of the lesson, which is the compound fraction. You're going to learn one new term, which is the reciprocal, and it's very easy. We're going also to calculate compound fractions. Let us start. What's the meaning of compound fraction? A compound fraction can have 3 forms: a number over fraction, a fraction over number, and a fraction over fraction. So compound fractions mean I have more than one fraction in the fraction. Okay, so if you look at the first one, we have n over a over b. So I have a number over fraction, or a fraction over number, or a fraction over fraction. How do I solve this? This is very easy. You will see that we have an easy steps to calculate this, and it's very easy. But before we continue, let us just remember that the opposite of a is minus a. So the opposite of 2 is minus 2. Now what's the reciprocal of a? Reciprocal means, you know this, when we do the flip or the inverse. So what's the flip or the inverse of 5 over 2? It's 2 over 5. So what's the flip of A? 1 over A. Okay, so this is very easy. I have only one rule to calculate the compound of fraction, whether I have number over fraction, fraction over number, or fraction over fraction. One rule: far times far over near times near. So the far numbers are A and D, and the near numbers are B and C. So B is near to C, A is far from D. So we'll multiply the far numbers over the multiplication of near numbers. So far, here, far times far, we put it as a numerator. Near times near, we put it on the denominator. Like, I'm going to give you example. 1 over 3 over 5 over 7. We put an equal and a fraction like this. Far times far, it's 1 times 7. Far times far is 1 times 7. Near times near, it's 3 times 5. I check if I can simplify. If not, I multiply them directly, and this is the fraction. So one rule only for all of them: far times far over near times near. Let us solve these exercises before we continue. We have a number or a fraction 3 over 2. What's the opposite of 3 over 2? It's minus 3 over 2. But what's the reciprocal of 3 over 2? It's 2 over 3. So you flip the fraction upside down. What's the opposite of if the opposite of A is 4, so what's A? It's 4. What's the reciprocal of A? It's 1 over 4. So what's the reciprocal of 4? 1 over 4. So as if it's 4, it's 4 over 1. So you do 1 over 4. What's the opposite of 0? 0. The reciprocal of 0, it's also 0. Now, if the reciprocal is 6 over 11, then what's the number itself? It's 11 over 6. And what's its opposite? It's minus 11 over 6. If the reciprocal of A is minus 0.4, then A is minus 10 over 4, because 0.4 is 4 over 10. So when you do the reciprocal, it's 10 over 4. And the opposite is 10 over 4. Now you have to guess here a number. You multiply it by 13 over 17 equals 1. The only time when you multiply two fractions and you get 1 is when you multiply their reciprocals. So 13 over 17 times 17 over 3. Sorry, 17 over 13. Try to guess the second one. What's the number? What's the fraction? You multiply it by minus 7 over 18 to get 1. It's 18 over minus 7. So you just do the reciprocal for all of them. For number 3 also 2y over x. And for number 4 it's the reciprocal of a, which is 1 over minus a. Now here, as you can see, in number 1 we have 1 over, I'm going to write it here, 1 over 8 over 7. This is a compound fraction, and I told you that you have to multiply the far by the far and the near by the near, but you have to get to have two fractions on each other. So you just put 1 over 1. So you add this over 1, and now you have far times far over near times near. So the answer is 7 over 8. The same thing in number 2. We put 1 over 1, and you get 1 times 4 over 1 times minus 3, which is 4 over minus 3. The same thing in number 3. We have only 3, so you put it over 1, and you multiply the far by each other and the near by each other, so it's minus 1 over 9. In number 4, it's very easy. You just multiply the far by each other and the near by each other. So it's 5 times 3 over 9 times 8. Always simplify before you multiply. So the final answer is 5 over 24. And now 9, you put it 9 over 1 and you multiply the far by each other and the near by each other. So the answer is 27. And here I want you to pay attention very well. How do we solve this fraction? As you can see, we have a fraction over a fraction, and we have operations. We have many things to do here. So I want you to pay attention. The first step and the most important one is to put equal and big line of fraction. The big line of fraction should be at the same level of the big line of fraction of the first one. Please pay attention to this. Now, if you look at the numerator, I have 1 plus half, so I have to add these. We put 1 over 1 and we multiply by 2. So what do we get? 2 plus 1 over 2. The same thing in the denominator, we put it over 1 times 2 times 2. So it's 2 minus 1 over 2. Equal and big line of fraction before you do anything else. What do I have in the numerator? 3 over 2. What do I have in the denominator? 1 over 2. And now I have a compound fraction. What do I do? Far times far over near times near. Far times, before you start, you put the line of fraction, okay? 3 times 2 over 2 times 1. And now you simplify, the 2 goes with the 2, and the final answer is 3 over 1, which is 3. Can you see? All this compound fraction, it gives you only 3. Now, minus 4 over 15 divided by minus 7 over minus 3. This is an easy one. It's not compound, okay? So, minus 4 over 15, keep, switch, flip. The first thing you have to know is that the minus simplified with the minus. 3 divide 3 is 1, 15 divided by 3 is 5, and that's it. And now we multiply, we get minus 4 over 35. Now in number 9, we have compound fractions, so the first thing you have to do is to put an equal and big line of fraction. Numerators alone, denominators alone to get only one fraction. 2 over 1 and we multiply by 4, we get 8 minus 3 over 4. Over 1 times 2 times 2, so it's 2 plus 9 over 2. Equal, big line of fraction before I start with anything. 8 minus 3, it's 5 over 4 over 11 over 2. Numerate far times far over near times near. Equal, big line of fraction before anything else. 5 times 2 over 4 times 11. 2 divide 2, 1. 4 divide 2, 2. So it's 5 over 22, and that's the simplest form. I wish you find it very easy. So as long as you follow my steps, you're going to find the compound fraction very easy. Don't forget to solve the exercises and check your answers on the PDF lecture. Good luck.